Now we welcome Dr. Hannan Adeel, who will be speaking on advancement in image enhancement, trends and perspectives. Dr. Hannan Adeel, I request you to share the screen and start your presentation.
All right. Thank you, Dr. Inamullah Khan, President of ICETI, and Arusa and Wakar and Wakar, the organizers. And I am Dr. Hannan Adeel, and I am Associate Professor at Department of Computing at Hamdard University, Islamabad, Pakistan. Basically, the main purpose of image enhancement is to produce better quality images from a single or multiple input images. As the image quality may suffer from a variety of issues during acquisition, storage, and transmission. And these phenomena are mainly due to object or camera motion and sensor limitations and environmental issues. Here I have included some examples of degraded images. As I'm using slides from my recent presentation, so I have included a limited number of degraded scenarios. For instance, in figures A, B, C, we can see a blurring issue, a noisy image, and a hazy image. Similarly, in images D, E, and F, we can see resolution issues, color artifacts, and contrast issues. In addition to these, there may be several other artifacts of degraded images. Here is basically a classification of image enhancement schemes, and as I focused on three areas, namely multifocus image fusion, multi-exposure image fusion, and image band sharpening. So basically, in multifocus image fusion, we have two images like this. As shown in the upper left, we can see that there are two inputs, and there may be more than two inputs in actual. And then what is the output? What is the desired is that we get an all-in-focus output. So there are some other applications. For instance, in the lower left, I have included a multi-exposure image fusion scenario. And in multi-exposure image fusion scenario, we have multiple images of various exposures. However, recently I have dealt with a limiting case, that is a challenging one, in which only we have large exposure ratio images. And what is meant by large exposure ratio images is that we have a very bright and only a dark image. So it means we will be having only two images. And it should be mentioned that when the number of inputs is limited, for instance, like only two images, then it becomes challenging because the exposure ratio for these two images will be very high. And then what will be desired? Obviously, to obtain a well-exposed image. All right. And one more thing, one more area which I would like to discuss is the defencing, image defencing, in which we get images with the fences, and of course, what is desired is that we want defocused images, right, as shown on the upper right. All right. Similarly, one more area which I have dealt is image band sharpening, and in image band sharpening, we have images from different sensors. For instance, here we can see that two images in the lower right, two input images, which are basically pan and low resolution multispectral images. The upper one is the basically pan image, which is we can see that it is black and white, or we can say a grayscale image, and without any color information. And colors are also known as spectral information, which are contained in the multi-resolution, multi-spectral images. However, they have a resolution problem because these images come from two different types of sensors. One type of sensors, which are basically the pan images, they are high resolution, but they lack the color information. And the other one is basically they have resolution issues. They are low resolution images, but they have the spectral information, the color information. All right. And we are interested in generation of high resolution multispectral images. Means we need the high resolution from the pan sensors and the spectral information obtained from the multispectral images to combine them. And this thing is known as image band sharpening. So basically, these are the four areas I will talk about these. Let's come back to the classification over here. All right. So I have briefly described what is meant by multifocus images, multi-exposure image fusion, and image band sharpening. And all these areas are basically in image enhancement and image fusion. So there are different types of methods we can see. I will keep it brief due to time. All right. So here we can see that multifocus fusion methods can be categorized as spatial domain methods, transform domain based methods, sparse presentation based methods, and deep learning based methods. Whereas multi-exposure fusion methods, they are a bit different. Different techniques are used as compared to the multifocus image fusion. So here we have techniques like pixel-based methods, patch-based methods, obviously transform domain-based methods, and some optimization-based methods and deep learning-based methods. Whereas for image pan sharpening, there are component substitution-based methods, multi-resolution analysis-based methods, and optimization-based methods and deep learning-based methods, and some hybrid methods as well. This table shows a systematic literature review on image fusion techniques, and as the first column shows that these are different methods of schemes, and then in the center column, the main techniques are listed over here that are used. All right. So these are basically image fusion techniques, and they use techniques such as histogram equalization, parallel transformations, sparse presentation, wavelet transforms, matrix decomposition, and DNN, CNN. These are based on deep learning based methods. Somehow there are limitations as well. For instance, spatial domain methods perform inaccurate segmentation and blurring artifacts, and also we have to consider the boundary areas. Whereas the sparse presentation-based methods, they are timely, sometimes inefficient, you can say, and also they suffer from noise removal. And similarly, transform-based methods, they suffer from computational burden. And deep learning-based methods, we need basically more data, and also use of GPU, etc. These are basically the limitations of deep learning-based methods. As I have introduced you with my second area, that was image defensing, and schemes for image defensing can be classified as model-based methods and deep learning-based methods. So both have their own pros and cons, definitely. Deep learning-based methods have general issues like training data, multiple GPU use, etc. Whereas the model-based methods for image defensing, they have limitations like segmentation and images. For instance, we have with flash, at times we have images without flash, etc. And techniques for the model-based methods, they are like based on color similarity, multiple thresholds, subtraction, image mating, etc., along with the image in painting techniques, right? So the third area is basically image pan sharpening, and in image pan sharpening, techniques like component substitution, multi-resolution analysis, and deep learning-based techniques are used. So here, basically, the information, as I described earlier, is of two types. One is spectral information, and the other is the spatial information. Spatial information, we mean like related to resolution. So, and the spectral information, which I already described as the color information, right? So, all of these have basically limitations as well. Somehow we are not going into details. Let's move forward. The second point I would like to talk about is image fusion quality evaluation. For all, as there are different areas, so we have different types of image fusion quality evaluation. So here, some of them are listed. For instance, for image pan sharpening, we use metrics like QSAM, which is basically spectral information, and similarly universal image quality index, and spatial correlation, and global admissible relative error of synthesis and global error. So basically, there are different types of image fusion quality evaluation metrics. So these are used for objective evaluation of the image quality, and which are mainly based on different aspects. They are they are based on information transferred from the source images to the resultant images. Similarly, for instance, while we're considering a restoration of images, for instance, in image defensing, then suitable image quality matrix will be based on structural similarity, and similarly based on measure that closeness in given images like normalized absolute error, etc. And these can be categorized as reference-based and non-reference-based image quality matrix. With what is meant by reference-based? we have an ideal image. For instance, we have a resultant image, which is also known as ground truth, right? And for cases when there is no ground truth is available, only we have source images, then we use reference less or no reference image quality matrix. The lower three, like QBRIS, QNIQE, QPIQE, these are examples of reference less image quality matrix, right? So image quality matrix is also an area of research, because we consider that which matrix are suitable for what type of application. And this is also basically a good research area. People who like mathematics, they can pursue such kind of research as well. All right. So as I have already told you that I am using slides for my recent presentation. I have included over here problem statements and research objectives, and I have not removed it from over here, just to give an example that how we can set problem statement and research objectives. For instance, as I have introduced the areas for multifocus image fusion, multi-exposure fusion, and image pen sharpening. So I will just look at the one of these, which is the central one, which is to develop and evaluate MEF. MEF methods means multi-exposure fusion methods, right? So that generates well-exposed images for, basically this was my area, that is large exposure ratio images, and what was desired by maximizing visual information in source images. And this is one part, and the other part is that and contrast enhancement in low contrast regions while preserving structural details and avoiding color artifacts. So these are the examples, all right, for the problem statement and research objectives. What type of limitations do we face? We face limitations related to accuracy and robustness, and or to reduce computational complexity. All right, let's focus on one of the schemes. And this scheme is basically image fusion using curvature minimization and morphological filtering. All right, so in the block diagram, what we have shown is this input 1 and input 2. Input 1 means this is a multifocus input, and input 2, it is also multifocus input, and different areas of these images are in focus, right? And then this is basically a spatial domain-based method that we have recently proposed. And basically what was desired is that we get the features in the focused areas from both of the inputs, right? So here what we have proposed is that we use curvature filtering and range filtering to get the focused areas in both of the images. And also then we perform the spatial frequency based focus maps. And then once we get the focus map, and what is meant by the focus map, the map that shows the focused areas in an image is basically a focus map. Once we get the focus map, we define the focus map. Why do we define the focus map? We define the focus map in order to clarify or to set the boundary between the areas from the source images. And then we obtain the fusion weights to finally fuse the images. So this is basically the block diagram. And here is basically a visual representation as well. Firstly, they were pre-processed to make them more suitable for further processing. And then the curvature energy minimization was applied over here. And we have shown the images on the right, A, B, C, and D. A and B are basically curvature energy minimization of the source images. Here, this might appear grayish to you, but on different machines, it looks differently. And if closely observed, we can see that the areas where basically the areas are focused in the source images, they have still some basically information, while the other part is almost gone smooth. All right, so smoothing is basically to lower the information. By smoothing, basically curvature energy minimization is a smoothing algorithm, and this smooths the image. So where the parts where the images which are not in focus, we smooth them, and when we smooth them, then we only get the information in the focused areas, because they will still have some information. Also, the spatial frequency is utilized to obtain the focused areas, and then these are combined like this. And here also basically range filtering is also applied, as I had showed in the block diagram. Then later we applied the range filtering as well. So then we get the focus map. So here we can see that as compared to the source images were here, A and B, and in the first input, which is the input 1, I have labeled that this is basically the near focused image, whereas the input B is the far focused image. So on this slide, we can see in the images C and D that we get initial focus maps. But here still we need to process further these focus maps, and then morphological filtering comes in. Basically, these are filtering techniques which are used, and then to remove the small objects, and then to get a better focus map. Somehow in figure B, we can see that although the gaps are filled, and then still there are some spikes, and this can be done by using smoothing, blurring, and etc. A combination of some steps, which gives us a very good basically boundary. All right. So, and then these are basically used as the fusion weight maps to obtain the fused image from the source images A and B. All right. And basically we compared with some of the schemes, and these schemes basically they are named over here, and A, B, C, and D, E, F, G, and H. All right, all these are basically the focus map generated by different schemes. And here we can see basically this is the major step, as we can see in A, B, and in D, that the focus maps are not properly drawn. So this makes the difference. This step is crucial. And then we can see that here in the proposed scheme, this map is better as compared to the rest of the schemes. And this is mainly due to the techniques we have used to extract the salient features from the focused and defocused areas, and then by refining of the focus map. So based on these, we get better results, obviously, and then that this works. And also here are some of the close-ups. We can see, for instance, here we can see that some of the parts in figure C, they are blur, and also in the figure E, this is basically bilateral filtering applied over here, and this is some of the schemes. All right, so some results are reasonable, some are not, while proposed scheme appears to be better as compared to other schemes as well. All right, here are some more results I have included over here, and similar artifacts can be seen in GF and some in BF as well. All right. So basically, the evaluation of image fusion techniques is of two types. One is basically the visual comparison, which is over here, and the other one is basically based on the matrix, basically quantitative analysis. And these are basically, we have used QMI, QX, QM, QP. These are basically the matrix. All right. So due to shortage of time, we will not go into detail. And as the higher values, they show better performance. All right. So considering we have short of time, so I will go to the basically conclusion part over here. So some of the points are here like that. We can work for large exposure ratio images, which is one area of research which I have dealt. Similarly, the results are shown over here in the lower left image. And in image pan sharpening is another area we can work on this, in which what is desired is basically what is desired to minimize the distortions, which are basically spectral distortions and the spatial distortions simultaneously. So some schemes, they focus on reducing the spectral distortions, while some schemes try to work on spatial distortion minimization, and what is desired to minimize both simultaneously. So all right, and also we can work on matrix, and there are many other research perspectives in image enhancement. So I think I should conclude my presentation over here. Thank you.
Thank you, sir, for your enlightening presentation. I would must say your topic image enhancement scheme was very interesting for us. Does anyone have any questions or comments for Dr. Hanan Adil before we move forward?
Okay.
Thank you so much for your
Okay.
kind words and participation, sir.
Okay. Thank you, Rosa. Thank you, everyone.